Good day, ladies and gentlemen. We are going to be looking in this session at 3.2 linear equations in two variables. Now, linear is an adjective that describes a line. So these equations, if we were to graph them as old Rene Descartes said we could do with his rectangular coordinate system, they will form a line. Now, you and I are going to be looking at equations of lines in more forms than one. Just a little preview of coming attractions. You and I are going to be looking at something like this in the very near future. Y equals mx plus b. Most of you remember this to be something called the slope-intercept form. That when I solve a linear equation for y, the number in front of x is my slope, and the constant number at the end is my y-intercept. That is a very helpful form of the line because it reveals a lot about the line. You and I today are going to be looking at this guy, the standard form of a line. So many x's plus so many y's equals a number. Let's look at an example. How about that? 3x plus 2y equal 12. This is defined to be a linear equation. Why? Because it just has x's, y's, and numbers. If you have an equation that just has x's and or y's and numbers, then you have yourself a linear equation. Let me be real specific about that. It's not linear if you have a power other than just the understood one here. For instance, this is not linear because of that right there. This is not linear. This is not x to the first power. In fact, you and I are going to discover a little later that the square root of x translates to x to the 1/2 power. This is not x, x's, y's, and numbers, so it doesn't count as a linear equation. Oh, by the way, this is a linear equation. It has x's and or y's, so either x's or y's, and a number. That's a linear equation. It has x's or y's and the numbers. And of course, having x's and y's and numbers makes it linear. Check this guy out. Linear? What do you think? Not linear because of this term right there. That is not an x or a y, that's an xy. So unless it has x's, y's, numbers, any of that combination, it's not linear. So keep that in mind because some of your problems on Hawks will ask you, hey, is this thing linear? All right, again, this is called standard form. And the benefit of standard form is it's standard. If anybody anywhere in the world puts any equation of this line in a form like this, it's going to turn out to be the same standard presentation. So many x's, so many y's equal a number. Now this guy is very helpful for one very particular benefit, and that is it allows me to find something called the x and the y intercept. One thing we're going to discover about a linear equation that has both x's and y's is that it is a slanted line. It's not horizontal, it's not horizontal, it's not vertical. It's a slanted line. Now watch this. Any slanted line is eventually going to cut the y-axis and the x-axis. Any slanted line is eventually going to cut both the y-axis and the x-axis. So if you have a slanted line, it will eventually cut both axes. It has what is called an x and a y intercept. May I remind you of something that we observed about every single point on the y-axis. Do you remember this? Every single point on the y-axis has an x value that's 0. So here's a strategy. Watch this. To find the y-intercept, that is where my line cuts the y-axis. To find the y-intercept, I'm going to let x equal 0 and solve for y. This is important. We're going to be using this multiple times throughout the semester. To find the y-intercept, you let x equal 0 and solve for y. How do I do that? Well, here's my equation. Let x equal 0, okay? 3 times 0. That's just 0. 2y is 12. Y must be 6. So my y-intercept, I'm just finding my y-intercept is 6. It's going to cut the y-axis at positive 6. That's a point. It is x is 0, y is 6, 0, 6. There's my y-intercept. So whatever my line looks like, it's going to go right through that point. All right, second observation. Every single point on my x-axis has a y value that's 0. So if I want to find where my particular line cuts the x-axis, I'm going to let y equal 0, just kind of the converse of this. To find the x-intercept, let y equal 0 and solve for x. Here's my equation. Let's let y equal 0. That's just 0, so I get 3x equal 12. Divided by 3, x is 4. So wherever my line cuts the x-axis, it's at the point 4. We say the x-intercept is 4, 0. Looky there. Now you and I both know that all I need in order to define a line in a graph is 2 points. I can find a line simply by finding 2 points. The x and the y intercepts are convenient points to find. I have the graph of my line. So in Hawks, you will be asked to find the x and the y intercept. The way you do it is to let the opposite variable be 0 and solve for the variable you're interested in. And with those 2 points, you will draw your line on the graph when you're asked to. Here's a question. Check out this point. 1, 2, 1, 2, 3. You think the point 1, 2, 1, 2, you think the point 2, 3 is on the graph of this line? It appears to be, right? It appears like it goes through the point 1, 2, 1, 2. Appears like it goes through the point 2, 3. But I wonder if it does. And here's a good reassurance. I don't have to draw my line so accurately as to go exactly through the point 2, 3. I can find out if this point 2, 3 is on this line by a simple algebraic strategy. I can substitute 2, 3 into this equation and see if it gives me a true statement. How do I substitute a point into an equation? Well, keep this in mind. Every point is an x and a y. X is 2, y is 3. If this point is on this line, then when I substitute 2 for x and 3 for y, I will get a true statement. Let's see what happens. 3 times my x, which is 2. 2 times my y, which is 3. I'm wondering, and I'm going to put a question mark because I don't know, I'm wondering if that equals to 12. Let's find out. Oh my goodness, 6 plus 6 equals 12. True statement? Yes. 2, 3 is on the graph of the line 3x plus 2y equals 12. Hey, if I'd substituted 2, 3 into my equation and got something like 14 equals 12, a false statement, then I would have said, no, this particular point is not on the graph of that line. So I can determine if a point is on a graph very simply by substituting the point xy into my equation, see if I get a true statement. If I do, it's on the graph. If I don't, it's not. All right, standard form of the line, very helpful in finding both x and y intercepts. When I have the x and y intercept, I have my line. All right, let's take a specific close look at lines that are not slanted lines. Slanted lines have both x's and y's in them. Let's look at a line that is not slanted. This is a horizontal line. What is the equation of this horizontal line? Here's a good way to find the equation of a horizontal line. Find some points on this line. All right, let's see. 1, 2, 1, 2, 3. 2, 3 is on that line. 1, 2, 3, 4, 5. 1, 2, 3. 5, 3 is on that line. 1, 2, 3, 4, 5, 6, 7. Negative 7, 3 is on that line. Look at there. I've got 3 exemplary points on this line. Do you notice anything about these? Every single y is 3. Guess what the name of this line is? The name of this line, the equation for this line is y is 3. Oh my goodness, that's the equation of this line because every single point on this line has a y that is 3. So horizontal lines are in the form y equals some number. Y equals 27, y equals 14 over 2, y equals 88. Another way to think of horizontal lines is horizontal lines are lines with only y's in the equation. So if you have an equation like this, if you have an equation that has only y's, you may not know exactly what it looks like yet until you do some solving, but this is a horizontal line. Very important concept. Horizontal lines are lines that can be expressed linearly in the form y equals some number. All right, in the same way, let's look at a particular vertical line. Again, what's the equation of this vertical line? I don't know. Maybe we ought to find some points on this particular vertical line to find out. Let's find some points. 1, 2, 3, 4. -5, 4. -5, 4 is on the line. -5, 0 is on the line. -5, 8 is on the line. Hey, you got an idea as to what the equation of this line is? Are you noticing that every x coordinate is -5? So we shouldn't be surprised that the equation or the name of this line is x is -5. Why? Because every single point has an x that is -5. Vertical lines. Vertical lines, x equals -5, have the form x equals something. So if you have an equation, another way to think of it is vertical lines only have x's in the equation. If you have something like 37 pi x minus 1/15 x equals 207. It's an ugly looking equation, but it only has x's. And so I know, therefore, it is a vertical line. Now, let's remind ourselves once again about what we observed about slanted lines. Slanted lines have both x's and y's in the equation, and they have both an x and a y intercept. An x and a y intercept. Every slanted line will have an x and a y intercept. Well, check this out. Horizontal lines. They have a y intercept, but obviously they're never going to cut the x-axis. Horizontal lines only have y intercepts. Likewise, vertical lines. Check this out. Has an x-intercept, cuts the x-axis right there, but it will never cut the y-axis. So vertical lines have only x-intercepts. So when you're asked in Hawks to find the x and y intercept, it'll say, if possible. If it's slanted line, it's going to have both. If it's a horizontal line, it'll just have a y-intercept. If it is a vertical line, it will just have an x-intercept. All right, let's look at one more example, and then I think you'll be ready to do your Hawks work. Question is this guy linear? Now it appears, I'm not sure. Maybe we ought to clear out the fractions and see if this just has x's and y's. Remember, a linear equation is just going to have x's and or y's and numbers. So let's see if this has x's and y's, just x's, just y's. If it is, it's linear. Let's remember our two-step process. Find the LCM of my denominators. The smallest number that both 2 and 3 will divide evenly into is 6. So I'm going to multiply all parts by 6. And since these are fractions on the left, I'm going to put my 6 over 1. And since it's a whole number on the right, I can just multiply it like that. So remember, don't multiply the 6 times these guys. Let your denominators cancel. 2 will go into 6 3 times. That's why we're multiplying by 6, so my denominators can cancel. 3 will go into 6 2 times. So I have 3 times this. I'll go ahead and write it out in undistributed form. 2 times 8y is 16y, 24. All right, a little distributive. Got me some like terms, some y's I can get together. Question, is it linear? Yeah, it's got x's, y's, and numbers. Is linear. And that's about the only challenging example you'll have to find if something is linear when it's given in fractional form. And I think you're going to be able to handle it after that. So good luck with your 3-2 assignment.